Good morning. This is Ms. Biller back, and we're going to talk about 7.7 factoring special cases. So first, we're going to talk about perfect square trinomials. So the first one we have that's a perfect square trinomial is a squared plus 2ab plus b squared equals the same binomial squared, the quantity a plus b squared. The second perfect square trinomial is a squared minus 2ab plus b squared equals the quantity a minus b squared. And then we have another special case of the difference of two squares, which is a squared minus b squared equals two different binomials, the quantity a minus b times the quantity a plus b. Now, this must seem very familiar because in 7.3, we learned the perfect square binomials and difference of squares when we were multiplying special cases. So we have these formulas, but now we're going to go backwards and we're going to start with the trinomial and find how it's factored. So these would be our special cases, and it's a good thing to memorize these special cases. Save you a lot of time. All right, so let's factor each of these trinomials using our special cases. So we notice that this is 2 squared. So we can write this as 2x squared. And we note that this is 3 squared. So we can write plus 2 times 2x times the 3. So I have A, and B right here, plus the 3 squared, which is b squared. Okay, so that would be one way to do that. So we have, now we can put this into the perfect square binomial is 2x minus 3, and then a plus 3 squared. Okay. So that's how this will factor, 2x plus 3 squared. So that's using a special case. So now let's take a look at this one. We see, well, there's just 1 squared here for a, but this is 4 squared. So now we have x squared minus 2 times the x, and then times 4 plus 4 squared. So that means that this must factor x minus 4 squared. So both of these would be our factored forms. Okay, and we can check it with FOIL. 2x times 2x is 4x squared. 2x times 3 is 6x, times 2 is 12x, and 3 squared is 9. This would be x squared. X times 4 is -4, times 2 is -8, and -4 times -4 is +16. All right, let's look at a problem here with a cylinder. Right, so what is the radius of the cylinder that has a height of 3 inches and a volume of that equals pi times the quantity 27x squared plus 8x plus 3, and that's in inches. So we know the volume is pi r squared h, which basically is the area of this circle that area times this height here. So this is h. Let's see, I can put h right here. Okay, so that's h. All right, so let's substitute this in. So we have the volume we know is pi, and we have r here, which is 3, or h here, and we see we have a common factor here of 3. So we can take the 3 out. And when we divide this by 3, we get 9x squared. When we divide that by 3, we get 6x, and divide that by 3, we get 1. So now we have our height here. So, and we can write pi r squared h here. We're trying to find the radius. So if we divide by pi, and then we have our height, which is 3, so we're going to write times 3. So if we divide by 3 pi on both sides, that cancels this out, and this out, and that out, and this out, and that out. So after the dust settles, we have r squared equals 9x squared plus 6x plus 1. So this makes us think that this is a perfect square trinomial, and we know that this is 3 squared. So we suspect that this is hiding 3x squared plus 2 times 3x times 1 plus 1 squared, and it certainly fits the perfect square trinomial. So we have r squared equals 3x plus 1 squared. So that means that we have this expression here. I'll continue on another one here. Okay, so if we take the square root of both of these, and we know radius has to be positive, so we're going to take the square root of r squared, which would normally we'd have a plus or minus r when we take that out. But because a radius has to be a positive distance, we are only going to have a positive radius. So when we take the square root of 3x plus 1 squared, that just means we're going to get 3x plus 1. All right, so when we take the square root of this r squared equals 3x plus 1 squared, so we just do this to both sides, we get r equals 3x plus 1. Okay, so I think that's as good as we're going to get, and this is in inches, because we don't know what x is. So we'll just say this is our answer. Otherwise, we would solve for x if we knew what x was. All right, let's go with another problem here. All right, so let's factor each expression. So we see that we have x squared, and x squared is the same thing as x squared minus 8 squared right here. So that is a difference of squares. So we have x minus 8 times x plus 8. This one we have 3 squared x squared minus 10 squared. So we have a difference of squares again. So this is going to be 3x minus 10 times 3x plus 10. So these are pretty easy. I like difference of squares, difference of two squares. So now let's factor each of these completely. All right, so we have 4x cubed, 24x squared, and 36x. And this looks suspiciously like it has a hidden greatest common factor. So it looks like if we take a 4 out of each one of these, and we take 4x out of this, we end up with x squared plus, and 24 divided by 4 is 6, and x squared divided by x is x, plus, and then 36 divided by 4 is 9, and x divided by x is x. And we see, oh, this is 4x times x squared plus 2 times 1x times 3 plus 3 squared. So it fits our formula. We have a difference of squares. So this is going to equal, since it's an expression, we don't really need to write an equal sign. We're going to write the full factoring as 4x is going to be x plus 3 squared. So there we go. All right. So we look at 50. 50 isn't a square, a perfect square, and 32 isn't a perfect square. But wait, if we take a 2 out, then we get 25x squared minus 16y squared. It was hiding. So we have 2 times 5 squared x squared minus 4 squared y squared. So that fits a difference of 2 squares. So we can write this as 2. We don't want to forget the 2 we took out. So 2 times 5x minus 4y times 5x plus 4y. So there you have it, when you have a difference of squares. All right, that's it for today, and that's it for chapter 7. Good luck with the chapter review and quiz and test. Have a wonderful day. Bye-bye.